Good afternoon, this is Cody Hendrickson. Today we're going to be looking at pointer basics in C++ for the CS2420 class. And we're going to take a look at what we're going to be covering today in class with that. First, our outline, we're going to be going over pointers themselves as a concept, addressing some of the issues with them. We're going to be talking specifically today about the pointer operators, namely the pointer operator, the address of operator, the other pointer operator, which is the dereference operator, and the selector operator. So again, it's the same but different. And then we're going to talk a little bit about pointer math and how we can use it and why not to. And then we're going to do some code samples of pointers and seeing how they're actually used inside our code project. First of all, we're going to talk about pointer them. And so we're going to look at the initialization of pointers. There's a couple different ways to initialize pointers, and I'm showing them both right here. The first way is of type pointer name equals new type. And of course, we'll be calling the constructor for that. And so that's the way I'll be using most of the time with my class, is the idea of we declare the pointer immediately, since we're often using an actual pointer at instantiation. The other way of doing it, which is also a valid way of doing it, and we use this for some specific pieces, is the idea of type name, and then we'll give a name equals the address of operator on the variable. And this is when we have more of the idea of a temporary pointer, something we're only using at certain spots. And we'll make sure we have that available for us as well. But those are the two different ways of initializing a pointer inside our code in C++. So a pointer, again, is the idea that what makes it cheap to do things in C++ and even C programming. In C++ or C programming, if we are to pass parameters, normally we have the idea of we're passing around the entire object itself on the heap, making copies of it over and over again, which tends to use up large quantities of memory, and that's bad. We don't want to use up all of our memory inside our actual application. We want our memory to be used as necessary. Java has a way of avoiding this by the fact that everything in Java is a reference, and so it just handles that implicitly. In C++ and C, however, we have to actually explicitly define that we're using a pointer. And so what it does is allows us to actually have a simple way of referring to lots of different things. In class, we've already used the idea of my sriracha. And we talked about my sriracha on the Java side, where if I have my sriracha bottle, if you use my sriracha, it affects my actual sriracha itself. So even if I let you borrow my sriracha, it's still my sriracha. I am merely giving you a reference to my sriracha when you use it. And so that idea right here is the idea of sending that reference to it. I'm not actually giving you a brand new copy of a sriracha bottle, but rather you're simply just using my sriracha with your own pointer to it. And so that's what we're going to be doing with that, is by having a pointer, by having that little reference to it, it saves the idea of passing the entire object around over and over, making multiple copies of that object inside memory, but rather you can have a pointer to the same object, and multiple objects or multiple pointers can point to the same object itself, which can save a lot of memory and allow you to pass things around and do operations on things very effectively using C++. Like I said, Java avoids this by having everything that is an object be a pointer. It's implicitly handled, so you are always passing that reference. We see this easily in Java when we try to print out something that doesn't have a toString method, where it simply prints out an internal reference to its memory location. We're going to continue on with pointers right here, where we have the pointer itself, like I said, is merely the memory address. So it's basically just an int. An int itself is very cheap. That's what makes it so cheap in the idea of passing around memory. It's literally the address in the computer's memory system for the location of that value. And so by having a pointer reference to that, we have that pointer reference that simply is just that little small number. Numbers are cheap on the computer. And so we have that memory addresses right there. We do have a couple things, though, we have to remember about pointers. The biggest thing, though, is that pointers can't change type. You can't suddenly become a double pointer and switch that double pointer to be a car pointer. The pointers need to remain the same type. So my double pointer can refer to another double, no problem. But my double pointer can't point to a car. So I have to make sure that I keep the idea that my pointers are typed bound, so that if I type it as a double pointer, it's going to stay a double pointer. I can't suddenly start shoving cars or monkeys into it. And that's we've seen that process through all of our strongly typed languages, and in fact even the semi-typed languages like we saw with Swift. Once it becomes a certain type, it doesn't change that type. And so we need to keep that in mind. This is not Python. So we want to talk about operators. Now, in C++, operators are a huge deal, much more so than they were in Java. In Java, the operators are limited. We don't see any extra things happening. In C++, however, operators get changed for lots of different things. We have lots of operators that affect different things in different ways. Java has, this operator always works in this way. C++, you can make operators work in different ways, and so it can cause some confusion. And so because of that, we want to make sure we have a clear understanding of what the operators are and how they're used attached to pointers. And the way that we use those operators, it's very important for as you can see on the idea of compilation. We want to make sure we're using the pointers operators themselves properly, because we don't want to confuse ourselves. And if we confuse ourselves, we know we're going to probably confuse the compiler too, because the compiler is nowhere near as smart as us. So we want to make sure we keep this very straightforward inside our notes and inside our head. And this is something that will be why we're going to be doing that pretest again and again, so you can keep practicing with those pointers. So the first operator with a pointer is the pointer operator, aka the asterisk. And the asterisk is placed between the type and the variable name when you first create it. And it can be done either right next to the type, right next to the variable name, or how I've been doing it, right in the middle between them with a space around it. And that indicates that we are making a pointer of that type with this variable name. So the pointer operator can be attached to either of the words, either the type or the variable, or as I do in between, so there's a clear delineation. It's on the left-hand side of the equals sign. And so that's another way we can always tell that this is the pointer operator, because it's going to be on the left-hand side of the equal sign and not on the right-hand side or in the assignment side where a dereference would be. And so this is where the pointer operator is always going to be attached, though, with a type on one side and the variable name on the right-hand side. So it's in between those two. And that's for the pointer operator. That's how we create pointers. We just saw that a couple slides ago on the pointer initialization screen, where it's the pointer right in between that. That's where we create the pointer. It's the same one for something else, or for the other operator. We also have the address of operator, aka the ampersand. So the ampersand operator is how you get the reference of the location itself. This is where the memory location it's pointing to is. We'll use this especially for the idea of the assignment of a value of a variable into a pointer, because again, the pointer merely is a reference to that memory address. We also can use this for sending it to a parameter for methods or constructor calls. And most of the time, this is not going to be accessible by anything the user is going to see. When I say that, generally, 99% of the time, the user will have no need to know the address of a value. So we won't be outing this information to the console, nor will we writing this information in any files. The address of on a pointer is only going to be used by you for out purposes, say for the console or a file, merely to check to make sure you've got the correct parameter, the correct variable structure identified. Most of the time, though, the address of operator is only going to be behind the scenes code. Stuff where you're sending the address of something so you can assign it to something or to pass it as a correct parameter. So the address of operator is usually not going to be going attached to anything for output or for file output. So just as an FYI, this is one that you would use behind the scenes only to access the actual address of the location of the variable itself. So we'll be talking about that more later, though. We have the other use, though, of the asterisk, which is the dereference operator. The dereference operator is what allows us to actually affect the actual value stored in what the pointer is pointing to. So the dereference is how I get access to what's inside that value. So it's a way of dereferencing the address and getting into what's stored there. We'll use the dereference pointer, or not dereference pointer, the dereference operator quite a lot in our code. It's, as I said, it's the AKA I want to get what's inside that pointer, what the pointer is pointing to. I want what's there. And we'll place the dereference operator in front of the pointer variable. It'll often be placed in front of a pointer variable with the use of parens, and we'll see that here in class in just a second when we do our code review. But the dereference operator is how I get access to the actual object that pointer is pointing to, or value that pointer is pointing to if it's a primitive pointer. Our final operator we're going to be using we've already talked about this one and use this one in our code, is the selector operator. It looks like the arrow by combining a minus sign and a greater than symbol. And it is the shortcut operator. This is actually a little bit of syntactic sugar or shorthand code. What it is if we normally would get into an object by using the dot operator, we go inside objects with the dot operator. But because we're using pointers so often in C++, there is a bit of shorthand or shortcut or syntactic sugar that we can use to actually get into the objects a lot more effectively using pointers, and that is the selector operator. It's the, as I have right there, it's called the TLDR version, because otherwise what we have to do is we have to put a parens around the dereference operator, then the variable name, put the parens around that, and then do the dot on that. Versus we can simply do the name of the variable that's a pointer, the selector operator, and then go into that with its either method or data member calls. So the selector operator makes it so we can easily access the methods and data members of an object when we have only a pointer to it, rather than having to do the process of dereferencing the object first, making sure we catch it with parens so it contains that object as a whole, and then doing the dot on it. So it's a nice little bit of shortcut code that we'll be using all the time for actually referring to the interior methods of objects and or their data members. Now, the pointer math is something we can use. We won't be using it often in class, but I want to make sure we address it because you'll see it on the internet. You'll see it in textbooks and stuff. It's not the way we're going to be processing our arrays or our structures that we were using in C++, but we do want to make sure we address it because it's a way you can do that. And you can use plus plus and minus minus on the pointer itself to cycle through an array. Because you can add to the array, because in C++, arrays are contiguous spaces of memory. And so by adding to that memory, it will automatically go up through the next point of that in the array. And so that's what that the plus plus minus minus is. You can also use your comparison operators on a pointer. The comparison operators determine whether or not that is before or after that pointer in memory, which can have some actual value for projects. Right now, I haven't seen anything on our list of stuff that we're doing in class where we'll be using that, but you can actually use your comparison operators to determine if it's something's before or after in memory, which might be good for finding out if it's before or after a specific spot inside an array. But I think there's other ways that we can do that, and we'll continue using the more standard array structure. But I do want to make sure that we address that math can happen on pointers and is most often done as a reference to pointers in arrays. Here we have some code that we've already been using in class. We have our main from our previous project that we were doing, our second project we did last time in class. And we see right here we have the idea of our selector operator. The selector operator, again, is how we go inside an object that has a pointer reference to it. Here's where we have our use of the asterisk as the pointer operator, where we create a pointer. We create that pointer by saying type, pointer operator, variable name equals new, type, call its constructor. So we initialize a reference to that type as a pointer. We then go into that object using the selector operator. We can do the same thing for this using the dereference operator, and we'll do that right here. So we go right here, press enter, and we'll do a comment line. And I'm going to call the same base controller start, but we'll use the instead of using the selector operator, we will dereference it and then use the dot operator. So to use the dereference operator and the dot operator in combination, we first have to dereference it. So I'm going to put parens around this, dereference with the asterisk in front of it, and then the name of the pointer variable. So I've dereferenced that pointer variable. I surround it with the parens to indicate that I'm grabbing that whole thing as one point. I can then do a dot on that and then call its associated method, the start method, with a semicolon. So I'm going to do the same method twice now. The first time is using the selector operator right here, because this base controller is a pointer, and I'm using that pointer and I'm calling its associated method by using the selector operator. The second time I'm doing this, I'm dereferencing the pointer to get the actual object that the pointer is pointing to, and then I'm catching that with the parens around it. So that object has now been dereferenced and caught inside the parens, and then I use the dot to go into that object and then call it start method. So this is the same thing twice. So I'm going to rebuild the project with Command B. So as you can see, I have that same base controller right here. I create the pointer with the asterisk. I do the selector operator to simply use the pointer version of it. I do the same thing in a different way by using the dereference operator, catching it with parens to actually grab that object that has now been dereferenced from its pointer. And then I use its dot operator called start. So this is the same thing in a different fashion. We'll test that out by going to build this project over here. So I'm going to go right here, run as local C++ application. And we're going to maximize this so you can actually see this. So here's my second C++ class this week. We have the current value of the class is 21. Let's choose a new number of the class. And so we'll change that down to 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We'll put that down for 19. And welcome to my second C++ class this week. We can see we've called that method again. Our value is now 19 because we have reset that value. We'll add that up again. We'll say it's now 23. And the current value of class is 23. So the same method executed twice on the same object right here. I did base controller.start right here and base controller.start right there. One is using the pointer with the selector operator and dereferencing it. The second one one is using the pointer operator and the selector operator, so I can get that done. The second one was dereferencing that pointer and then calling the dot operator on that dereferenced object. Both of them are perfectly fine. I like the syntactic sugar of the selector operator It avoids this extra couple of bits of code, which can sometimes cause confusion, especially when you're trying to read what's going on and you have multiple pointers in something. So those are both valid ways of doing that. Again, we've already been using this pointer operator and using the selector operator earlier. If we go back to our afternoon controller.cpp, we've seen where we've been using the selector operator already with our this pointer that every object has access to. So I'm able to reference the current class count by using the this pointer and then referring to the class count and variable and using that same variable name convention we've already been using in class. So we have the selector operator, the dereference operator, the pointer operator, as well as the address of operator, which we'll be hitting in our next lecture because we'll be using that for parameter passing in our next time. But we want to just do a quick little review of what we were doing for that. Let's go back to the notes. So the big one is the pointer operator. Again, use that between the type and the name of the variable. The dereference marker, which always goes in front of the pointer, so you can dereference it to get access to the actual object itself, aka what's stored there. And finally, our selector operator, which allows us to go inside a pointer and access its internal methods and or data members. And so those are the things we'll be using with pointers, and that's our pointer basics lecture for the day.